Welcome to this episode of Bone Hunt, Discovering Dinosaurs with AI. I'm Bob Cheesebro. I'm a solution engineer and technical evangelist supporting OneAPI AI here at Intel Corporation. In this episode of Bone Hunt, Discovering Dinosaurs with AI, we'll be talking about PyTorch. And to start, let's talk about what PyTorch is. However, before we get to that, I want to acknowledge the help and support of my colleague Rahul Unikrishnan Nair, who has been instrumental in building both this video series and the workshop on which it is based. PyTorch is a popular deep learning framework for building applications, from recommendation systems to natural language processing. I chose PyTorch because it has been adopted by academia and is community-driven. It is also very similar to NumPy and Keras. A key motivation for using PyTorch was that I wanted to do this project on a CPU, and I didn't have a budget to run a high-end GPU node. If you can do the process on a CPU versus renting a GPU, you'll be able to keep your costs down. With PyTorch, I could go to their Torch Vision tutorials, which provided a great starting point for me to begin fine-tuning my model to fit my custom data set. There are quite a few pre-trained models, such as ResNet, which have been trained on the ImageNet dataset. Many developers assume that these pre-trained models are only good for images closely related to the images in the original ImageNet dataset. But this assumption is false. We demonstrate here that images from aerial photos, vastly different from any image in the ImageNet dataset, can be successfully used for fine-tuning the ResNet or similar classification model. Furthermore, fine-tuning worked well for our custom dataset. I think this is important for people to know and understand because many people get the impression that they must always start their project from scratch because their data is unlike anything else in the world. But that's not the case. Instead, you can work with pre-trained data sets and fine-tune your results. The technique I used is called transfer learning, and what it is that we use a pre-trained model, tweak the model's parameters, and change the last layer so that it can be used for the data sets we have defined. In traditional deep learning, you might need thousands of images, but with transfer learning, we are able to get good results in accuracy with just hundreds of images per class. And the training time is significantly less compared to training a deep neural network from scratch. My approach for using PyTorch was class-based. I defined a dinosaur class, but for some other use, you could create your own application class, whatever it is, whereas mine just happened to be focused on dinosaurs. Once I defined a dinosaur class, I implemented two additional classes, a trainer class and a metrics class. For this project, we had Class 1, Dinosaur Bone Finder. This defines what the model is, such as the ResNet backbone and any additional transformation layers. Class 2, Metrics class, which is used to enumerate accuracy and error rates. Class 3, Trainer class, helper functions to easily train the number of steps you take to train the model, and the key train and fine-tune loops. In the Trainer class, we provided a one-batch training mechanism that you can use to debug your model. You can get a model to the point where everything runs, but that doesn't mean that the model or the training has been run correctly. A quick way to test is to overfit your model by training it over one batch. And if you cannot overfit your model successfully in one batch, then clearly there is some issue with your training algorithm or your model design. We have implemented a data loader approach compatible with FastAI, which has become a more standard approach for many people. My approach was to use two libraries, PyTorch and the Intel extension for PyTorch, also known as IPEX. I use these because PyTorch is already Intel XPU optimized. The OneAPI Deep Neural Network Library, or OneDNN, which is part of the OneAPI library that Intel has open sourced, is the key ingredient accelerating PyTorch. With IPEX, you can do mixed precision training and quantized inference. IPEX is an end-to-end library that extends PyTorch's capabilities. If you install PyTorch for CPU or even GPU, you are already getting Intel optimizations by default. Intel has done all the work, and you get all the optimizations just by installing the standard package. The reason IPEX exists is, 1, it contains recent optimizations for XPUs prior to merging to the PyTorch mainline, so if you need to test them out, they will be in IPEX. 2, our future GPUs will be supported for deep learning with PyTorch using IPEX. Using IPEX is extremely easy. It is 1 to 3 lines of change to your code base, depending on what optimizations that you need. Framework developers using OneDNN provide us with 1. Improved performance of frameworks you already use, such as PyTorch and TensorFlow, as well as others. 2. Help developing faster deep learning applications and frameworks when using optimized building blocks. And 3. Targeting of applications optimized for Intel XPUs. If you're familiar with PyTorch or deep learning frameworks, you'll likely have an intuitive understanding of our implementation. The overall approach I am using targeted dinosaur datasets, but the approach could be used for other datasets like forest fire mitigation based on aerial photos or satellite images, providing analysis of road patterns, foliage density, and weather conditions. Regulatory compliance of public land management based on aerial photos. Interplanetary water exploration based on the classification of sedimentary structures on other planets. We encourage you to explore and share any additional use cases or examples you create. You can find links to resources, tools, and downloads, as well as where you can go to learn more about everything in this series in the description. Remember to like and share this video and subscribe to the Intel Software YouTube channel. In our next episode, we'll be looking at OpenVINO Toolkit. See you then as our dinosaur hunting adventure continues.
Let the adventure begin.